Yeah, I have to add this direction.
You ready? Cool. All right. We've got one more person coming along. Glad to see you on there. No, that's good. All right. So.
Should we close the door?
Yeah, that'd be great. Yeah, I think we're around about. All the other people will have to open the door and close it behind them. All right, hello and welcome everyone. So today at the Ethereum Engineering Group meetup, we have Horacio, who is going to tell us about Precompiles and JSON RPC APIs and creating them yourself to extend your very own Ethereum client. I know this is a talk not for the faint-hearted, but it's all good. So take it away, Horacio.
Okay, so in general, this talk is about how to customize Besu, and two typical places where we will want to do that is in the creating a precompile or creating a RPC. We will see exactly what are those and why they are interesting. In general, Besu is, and any Ethereum client is a complex thing with a number of subsystems, and we probably will not want to get too deep into that if we only want to implement some small functionality, relatively small functionality. In our case, for example, we will target the JSON RPC and the EVM. The JSON RPC section of the code is rather accessible, but for example, going into anything that touches the EVM is much deeper and more complicated. So we will see the ways in which we can go into that. First, the precompiles. So, what is a precompile? In general, I don't have access to my notes, so I have to improvise a bit. In general, the precompiles are to the EVM they look like a normal smart contract. They just are noticeable because they have an interesting address in the sense that usually it's a very low number, while a normal smart contract will have a random big address. They come provided by your Ethereum node. It's like a contract that is already there when you start whatever new blockchain with that Ethereum node. And it can be implemented in any language and do anything that your computer can. We will see exactly that anything, I mean, that asterisk will be important later, but the general idea is that it's a way to make the Ethereum node do whatever you can do with your computer. So, why precompiles? Why are they interesting? The thing is that usually when we have a smart contract, even if it's very simple, it turns into a much bigger piece of code, of bytecodes that the EVM execute. And each of those instructions has a cost, the gas cost that we pay when we execute a function in a smart contract. So even a small piece of code that to us looks like a small piece of code can turn into something big that can have some big cost. With a precompile, we avoid that. Instead of having all of that, which is lots of small instructions that have to be executed little by little with their own cost, blah, blah, with a precompile, we can just execute everything we can implement in the native language and make it faster and make it probably with a fraction of the cost. Another reason to use Precompiles is that since it's outside of the EVM, it's implemented at the same level as the Ethereum node. That code can do anything that the computer can do. So these are the existing Precompiles. Some of them were there from the beginning, let's say, but they can evolve and do evolve, the same as the EVM instruction set. One of the things that forks do in Ethereum is add new instructions, new precompiles. Here, I think the names are maybe informative enough. These are for implementation of cryptographic primitives. These four. Same as the three first ones, actually. Identity is just a very simple smart contract that just returns the same that you sent it to it. It's a way to test things. So, one question might be, what is the difference between an EVM instruction and a precompile? Actually, the difference is somewhat arbitrary. Since, for example, if you are familiar with what is an instruction in a traditional processor, you might expect that an EVM instruction would also be simple, which is, as for example, an instruction in assembler, in Intel, or whatever. That's not the case here. An EVM instruction can be from very simple, like shifting bits, to something very complicated, like a full calculation of a cryptographic hash. Also, the instructions evolve as needs are identified or as needed, and new forks can introduce new instructions. For example, something that is relatively as basic for traditional assembler as bit shifts only recently appeared with a recent EIP. The problem is that the same applies to precompiles. So it's not like any of those still help us to decide what should, if we want to implement something new in our Ethereum node or in our Ethereum blockchain, we still don't have a reason to decide for one or the other. So actually, the main reason we have seen to implement one or the other is that precompiles are easier to access from Solidity, from the high-level language, which is where we will usually work. Okay. If there is any question, anything, feel free to interrupt me. So, how to actually use a precompile? Same as the EVM, both are low-level mechanisms that are there, usually not touched by the user. The way to reach them is by programming Solidity and hoping that the compiler knows when to use those low-level mechanisms. For example, you could imagine that you could implement a cryptographic hash in Solidity, which would be very expensive because of the gas cost, or you could use a Solidity instruction which internally calls the EVM instructions or the precompile needed to execute that, to calculate that cryptographic hash. When we have, so that means that the compiler has to support those precompiles. But if we implement our own custom precompile, there will be no support, so we will need to use Solidity assembly, a part of Solidity, to be able to reach down and use directly those precompiles. That also means that precompiles, okay, they are not Solidity, but they live in a world of Solidity, so they have to communicate with Solidity code, so we need to keep the Solidity interfaces, the Solidity customs about how to deal with data. So let's see an implementation of a precompile. example, this is a simple precompile that we use that we created in the sidechains team for. Let me see. Yes. This is a precompile which returns information about the current blockchain to the Solidity contract. So a Solidity contract can interrogate the node about where it is running to make sure that since it's about cross-chain communication, we can be interested to know in which.
Do you know how to flip that into presenter mode?
Yeah.
There is a way of doing this so that the fonts will be significantly larger.
Uh-huh.
Yeah, I thought it was. That's so much easier.
But anyway, it's a lot of code, so I'm not sure if that helps. Anyway, the important thing here, I would say, is no, wait, this is not what I wanted. Yeah, I'll get down. I mean, I'll get back to the normal mode.
Okay.
If it allows me, yeah. Yeah, this is the. Is it showing? Yeah. This is a precompile which returns some information about the current blockchain to the smart contract. Even for something that simple, of course, you can need some code, but at least it's Java. It's not Solidity. It's usually a more a better known environment for programmers. And here, for example, we have some code that is needed to translate from the Java types to the Solidity types, so both worlds can communicate. Maybe more important or more interesting than this is how to actually we let the EVM node or the Ethereum node know that it can run our precompile. This is here. For example, let me see if it is here. Yeah. In Ethereum, okay, how in general does an Ethereum node know which precompiles it can use? We saw that Ethereum started with 4 precompiles, then new ones appeared. How do we do that? In general, the Genesis file, which is the beginning of any blockchain, starts by defining a consensus protocol for the case of cross-chain communication, for example, for the sidechains thing. We work on IBFT2. Next step is the Genesis file has to define at which block numbers new protocols can come to life. For example, Byzantium appeared on the block number for Recompile. And if we want to add our own precompile, we will have to define a new fork, which will come at any point. Could be fork, block 0, actually. And then we will have those precompiles available from that block number. So that's the way, the same, following that story is how we have to link our implementation or precompile into Besu. That's why, for example, for the sidechains team, we are using conceptually our precompiles are an extension to IBFT, so we piggyback on the IBFT code that is already there. That way we can work on a much smaller piece of code, which is the IBFT implementation, instead of going into the core of Besu, which is much bigger, much more complicated, let's say. One important detail is the asterisk I mentioned earlier. It's not really like you can implement everything your computer can do. The problem is that the whole point of the blockchain is that different nodes come to consensus. we need to make sure that all the nodes will be able to run the same precompiles and get to the same results. If not, that would be a fork. Every different node would have a different result, would diverge. A clear example of something that can be done: for example, have a random number generator, because every node would come up with a different random number, and there will be no consensus. Okay, so that's for precompiles. Any question for now?
So the compiled code is sort of like an average or least lowest common denominator of instruction sets that can do so. Things like different definitions of positive, negative, infinity, and those things. You've gone for a base. Yeah, so if you've got an AMD or Xeon or Intel instruction set, your precompiles for what's actually executed at the machine instruction level are base version, simple versions that you don't do any sophistication.
You mean
at the nodes? So if you go up to the instruction set to do something, what the precompile converts to machine language, you've got a set of instruction sets across all common CPUs. You're not taking advantages of any other built-in elements that, say, AMD would have or Intel would have.
You could, but for example, in the case of Besu, we are using Java, which is supposed to give the same results across different platforms.
Okay.
So in that sense, yes,
So
you are
the
going.
different nodes could be implemented in different languages, for instance, but for a precompile, like an EVM instruction, it has to be deterministic. So on all platforms, on all implementations that are going to be on that network, when you pass a certain parameters into that precompile, they all need to come up with the same result. Otherwise, you're not going to have a consensus. So it doesn't matter what you do.
Yeah, I just think there's in an early discussion things like rounding error or interpretation of long int and so on. Sorry, not int, but real numbers. There were some dilemmas.
Yeah, so I think the key thing is that precompiles aren't portable across clients. So every client has its own implementation of all the precompiles, and you have to do it in a way to degree. So the ones that are on mainnet, there's a set of tests, so they come up with the same thing like different EVM implementation. But it's not like you're providing, a precompiled contract that kind of ships with the blockchain or anything like that, and clients just pour it in and execute it. If you wanted to make this work on Get, you'd sit down and write it in Go and hook it into Get in a completely different way to what you do with your bases.
Okay.
And yeah, all the things about real numbers and that kind of thing is a concern for consensus. You've got to be aware of that in designing it, but for most things it generally works out pretty well.
Okay.
Having said that, one advantage of being in Java is that you can mostly hand wave that away.
Oh yeah. I mean, all the sort of high-level languages, Java, C++, and so on, C# and so on, they do the same. Yeah.
So let's go to the next part, which is remote procedure calls, or RPC. In general, what is a remote procedure call? It's a call to a procedure which is possibly in a remote server, in a remote computer. Usually we just call them RPC, and they can be used from calling contracts, calling functions inside of a smart contract, to any kind of interaction with the Ethereum node, from requesting information, changing some configuration, whatever. This is how an actual JSON RPC looks like in the wire, let's say. Let's say it that way. There is a method, there are parameters which in this case they are empty. This is the list of remote procedure calls that are in Besu, almost all of them. Most of them are standard ones. Some are standard across Ethereum nodes, which are the ones that start with F. Some are standardized by the EEA, like yeah, this one. Some of them are particular for Besu, like these ones. And we could implement our own call to do something specific that we would like to do, something that is not provided by the Ethereum node. For example, let's imagine that we want to get information about the EVM instructions that have been executed, or any kind of information that is not standard. So again, I'll show an example of what we are using in the sidechains team. Find it.
So you had a call to a precompile up for a sector.
Sorry?
You had a call to a precompile up for a sector.
So
But anyway, that's
no, actually I forgot it. So
yeah.
So this is an actual RPC method implemented and ready to be called, let's say. In general, in this case, for example, this is about returning the public key of a blockchain, which is still something specific for sidechains. Still is not totally implemented, but it's an example of a simple call that can be done. Not much to show, I guess, here.
Well, I know you've got. I mean, yeah, I wrote this code. It's changed already. So all of them implement the same. I mean, this is obviously just the Besu implementation, but your request comes in, which you decode. So this has got no parameters. But if you had parameters, you could decode the parameters. You do something, and then you give it a response, and that response could be anything. So yeah, so say rather than this, it was how many times have we done, I don't know, add, or how many times have we done store, you know, and you're gathering statistics in your Ethereum client about all the smart contracts that are being executed on that blockchain. How often do we use the store instruction? So, you know, I don't know, I'm just making up something, but you could do that and you could be gathering statistics. So you could pass in some sort of parameter to say, this is the instruction that I'm interested in the stats on, and it could return, say, the number of times that instruction is called. But you know, anything, I mean, invariably what it comes down to though is you look at the big long list of instruction of APIs that are available, and you say, but wouldn't it be good if it did this? And you would implement it.
So this is the implementation, and again the question is how to actually link this into Besu. And again, in our case, it was useful to just piggyback on the IBFT implementation. It's just easy to go to the smaller piece of code that is the IBFT implementation instead of looking for the exact piece inside of the Besu core where to insert our RPC definition. Am I showing it? Yeah. That's it. Now, we have been talking about extending Besu, and maybe you have heard that Pegasus Plus, the commercial version of Besu, actually supports plugins, or will support them soon. That's the thing. It's still not there. It's coming.
So plugin support is in Besu, not Plus. Plus uses the plugin support from Besu to provide extra plugins, and it's there, it's shipping. Been in for a couple of weeks.
But still is unstable. The API is unstable?
All stable APIs.
So, yeah. There's support for plugins, But still, the plugins, the API doesn't support things like the custom RPC or a custom precompile. So, still, if we want to implement any of those things, still we need to do what we showed.
But saying that, if you were interested in, you said, look, we'd like to have this as a plugin, and this would be really appealing to us. Put in, mention it on the Besu contributors channel, and mention it to people. Hey, I'm interested in doing this, because nothing like customer feedback to say I'm interested in doing it and for it to be implemented. And I can see Richard saying
plugins as in what normal sort of commercial other systems plugins, you mean?
Yeah. So you
like if I want property information in there and from.
Well, say for instance, you might say, look, I would like there to be the ability to have a JSON RPC plugin system, because I want to create my own JSON RPC plugin and I want to sell it. For instance, you might decide that that's something that you want to do, that you want to create your own plugin and you want to sell it. But we need, we need to create this capability to support the plugin that you plan to create. So say for instance you put something in directly into Besu, into your fork of Besu. At the moment you said, this is really good, I could become a bazillionaire off this if only I could sell it, and it was easy to integrate into Besu. Then maybe you could ask for that support.
So it would only cost half a bazillion to do that. You'd only be charged half a bazillion. Right,
well, that means you've made half a bazillion. You're still ahead.
True, yeah.
So the reason the plugin APIs at the moment are fairly limited is because we're gradually building them out. We want them to be stable, so we're not exposing just internals of Besu. We're being very careful about what we design and trying to think through how those APIs are likely to need to change in the future as well. So we're being very conservative about what we expose, but driving them as much as possible by use cases. So it is really useful to hear, I'd like to build a plugin that does this, and then we can work through it. And we've talked before, and I thought it was there actually, but it didn't make it in, about registering custom RPC methods. And that itself makes sense and is relatively straightforward to do, but then what else do you need access to? Comes to question. Precompiles are quite difficult because they drop into the middle of the UVM and have access to tons of state and state accounts, and just half of Ethereum gets kind of tied up into them. So they may take more reasoning about, but there's been some demand.
Any question? I'll go to the summary and we can ask. So, as we saw, the precompiles allow us to add functionality to the EVM. For example, to do more for less gas, to access things outside of the EVM. The important part here is that all nodes need to support them to avoid forking. Another thing that we can customize easily in Besu is adding our own RPCs, which allow you to add functionality particular to one single node. In this case, you don't need it for consensus. And for both implementing precompiles or RPCs, you require knowledge of the Ethereum client, of the architecture. This can be non-trivial, but it would allow you to do things that you can do in any other way, either from Solidity or in general with a standard Ethereum client. Questions?
So you mentioned gas at the top there. So is there a predefined amount of gas that you take into account for the precompile?
You define it for every precompile. You can define the gas cost. Correct me if I'm wrong. Yeah. In general, since the let me see.
So for stuff that's part of the mainnet clients, there's a process of lots of negotiation and lots of benchmarking before they, code on this is the gas cost, because you want to have the gas cost match the physical cost. But say if you were setting up your own blockchain and you said, hey, we're going to have these extra precompiles in there, it's up to you to work out what you want to charge. You might charge 0 to do that poll, or you might charge a whole heap. It's up to you.
There is a minimum gas cost that applies, because when you call to a precompiled contract, it is a call operation. So the cost of that call is always in there. Then plus whatever the
Still might EVM byte code, just to call that.
Yeah. So it's just like calling a real contract in that you have, I think it's 400 gas or something that you call over. It's not even more than that, but whatever that is. Just like if I written a contract, it's Solidity neutral that there's a charge for that call plus whatever it costs to execute the actual Solidity contract. Precompiles, it's the same thing. The call plus whatever the precompiled charges.
In general, the precompiles when they were defined and standardized, that's where also the gas cost got defined. So it's all part of the standard, let's say. And in particular, when you implement your own precompile, you have a function in which you can define the cost of gas, right?
Which I just randomly put as 10, but it does not reflect in any way, shape or form the amount of gas cost. I just thought initially putting it at 0 might be a bad idea, but 0 is probably just as good as 10.
Anyway, in the context, for example, of an IBFT private blockchain, it's very possible that you will not be even paying attention to gas. Depends on, so. Other questions? So then let's go to the next box.
Yeah. We should go to the next. Yeah. What's coming up next? Yeah. Sorry. And so in a few weeks' time, actually, can't even be 2 weeks, can't we? In just under 2 weeks' time, we've got this symposium on distributed ledger technology, the SDLT, and that's going to be at Griffith University Nathan campus. I think it's almost at the point of after the early bird rate finishes. And then the day after that, I'm going to talk about Ethereum reorgs, forks, and selfish mining. I have not written one word on that yet, so I've got a fair bit to do. And then we're all going to take a break for Christmas and New Year, and back in February, that's a Monday, and I'm going to talk about introduction to Ethereum and blockchain. I'm going to talk about, as well as the stuff that I've talked about previously, I'll talk about ERC20 and 721 contracts, and stable coins, and all these altcoins and all the other obscurities that you hear about. And Grant is potentially going to present half of it. He'll present the half, anyway. Grant and I will sort
the less complicated half.
I don't know. It's all complicated. Anyway, and then, then I'm going to talk about cross-chain. So, essentially the programming paradigms that you need if you're developing cross-chain contracts and what that looks like. And I can't remember what the latest name for Artemis is, but Adrian's going to talk about it.
It hasn't been decided.
Okay. So maybe we'll call it Up in the Air Ethereum 2 Client Architecture. Anyway, by February 19th, 2020.
Hopefully we'll have a name.
Hopefully we'll have a name. I don't know, as long as it's not 2021.
Early 2020, wasn't it? Ethereum 2?
What's the story on that? The proof, you mean proof of stake?
Yeah, you mean getting the beacon chain up and running live. This is it.
The aim is to get the beacon chain up and running, which is just phase 0, no transfers, no stake execution, but staking. Get that up and running by end of the first quarter next year.
Oh, okay, right. Yeah.
Some crazy person mentioned January 3. That will not happen.
That's
not
what
a chance.
that's what I had in my mind.
Yeah.
Yeah.
That was kind of a random. Wouldn't it be nice if and then it kind of went through Twitter as, hey, it'll happen.
Yeah.
It will not happen.
A political aspirational goal.
Yeah.
And I
Q1
mean-
is fairly aspirational.
Well, I
There's a lot of
mean,
testing
this
going
is the
on.
thing. It's hard. I mean, you can think that you're on the I mean, it's not quite. It's not as R&D as the cross-chain stuff, but it's still out there. And you can think that you're almost there, and suddenly there's another huge thing that you hadn't really thought. You know, you'd sort of known about, but you hadn't thoroughly thought through. And then when you actually come to it, it suddenly all gets pretty complicated. Anyway, look. Thank you again, Horacio, for presenting. Yeah. All right. See you all in just under 2 weeks' time at the SDLT or at the meetup in 2 weeks. Bye-bye.